All right, so in 2.7, we're going to talk about graphs of rational functions, specifically like how to hand sketch them. And so we're going to have a big list of steps here, 6 steps to help us graph rational functions in this form. So if I can have someone pause the video, just so you have time to write all of these down. I'll let you guys pause it now, and then I'll go over them kind of quickly. Okay, so our 6 steps. The first one is we need to factor the top and bottom completely, and we're looking to simplify. So, importantly, we're looking to simplify as much as we can. Okay. Next, so if there are any factors that have an x in them and they cancel out between the top and bottom, it's important to know that what would have been an asymptote, a vertical asymptote, isn't an asymptote anymore. It's a singular hole in our graph. We talked about those where like your graph may curve, get to that x value, you just have like an open dot, and then it continues curving. Okay, so that's possible. We run into one of those. Next, we're asked to find the y-intercept. So we want to find where my function equals 0, or not equals 0, I'm sorry, when we plug in 0 for x, that's how you find the y-intercept. So plug in 0 for x, so we're going to find the y-intercept. Next, we're going to find any x-intercepts. This is where we set the numerator equal to 0. So set the numerator equal to 0, find any zeros. 4, find any vertical asymptotes. That's when our denominator equals 0. Division by 0. And the bottom is 0, that's what gives me a vertical asymptote. So our horizontal asymptotes is what we're going to find next and sketch those in. That's where we compare the degree of the top or bottom. Remember, if like the degrees were even, you did like the ratio of the leading coefficients. You might have to look back into 2.6's notes. When it's top heavy, that's when it's not a horizontal asymptote. It's some other type of asymptote. I'll talk about that next class, like the slant asymptotes and quadratic asymptotes and weird stuff like that. And when the bottom has the higher degree, it's always y equals 0. Plus or minus if there's some weird k value on the outside, but don't worry about that. That'd be like if there was like a plus k. This would shift my graph up or down. So my horizontal asymptote would move by that value, but we don't really have to worry about that. Okay, and then we're going to plot in any points needed. So say once I have my horizontal asymptote and vertical asymptote, I want to know, like, does this graph come in really close to those asymptotes when it's bounded, or does it come in really soft, etc. So we're going to need some points kind of close to these vertical asymptotes, some x values that we plug in to figure out how close this is really coming in, on our particular graph. So we're going to need a couple extra points, and then of course we're going to connect them with our nice smooth curves that are bounded by my asymptotes. Okay. So let's take a look at some of these. All right, so in short, we're going to simplify and look for holes, or y-intercepts, x-intercepts, any vertical asymptotes, horizontal asymptotes, grab some extra points, and plot in our smooth curve. Okay, so we've got a few examples we'll do. So sketch the graph of each function using our 6-step procedure. So our first example is x plus 1 over x. Okay, so I can't really factor the top or bottom. This is like its own factor, x plus 1. And this is its own factor, x. And remember, you cannot cancel those x's. There's addition or subtraction, can't do it, right? So this is not simplifiable, which means there are no holes. Okay, next to find my y-intercept. We're going to plug in 0 for x. So when I plug in 0 for x, I get 0 plus 1 over 0, which gives me 1 over 0, which is undefined. Okay, so what that tells me is there is no y-intercept. What most likely that means is my vertical asymptote's going to be at the y-axis. And in fact, we'll see that's true in a minute. Okay, for the x-intercept, I plug in 0 for y. I want to know when the numerator equals 0. So when does x plus 1 equal 0? Oh, I'm holding down the wrong button. And obviously subtract 1 over, and that's when x is -1. So my x-intercept is -1, 0. We can plot that on my graph. -1, 0. Okay. Next, we're going to look for any vertical asymptotes. So when is the denominator? When does x equal 0? Well, that's it. That's when x equals 0. That's my vertical asymptote. And when x equals 0, that is the y-axis. So we'll kind of plot that in. Sorry, this pen's not very accurate, so pretend that's all nicely on the y-axis. All right, next up, any horizontal asymptotes. That's where I compare the degree of the top and bottom. And in this case, because they're both the same degree, we can think of this as 1x to the first and 1x to the first. We look at the ratio of their leading coefficients. So 1 over 1. My horizontal asymptote is the line y equals 1 over 1 or y equals 1. So y equals 1. I'm going to plot in my horizontal asymptote. I should label these in x equals 0. These are my asymptotes this time. Okay, so next we're asked to find some extra points. So we're going to make a little table. It's not very straight. Okay, so remember that when x is 0, that's where my graph is undefined. But I want to pick a few points around that. Generally, I don't want to be super close. I mean, 1's not a terrible option. But maybe I'd want to go like 1, 2, and 3 to get a good picture here. So maybe like 1, 2, and 3. Should give me a pretty good picture. And of course I can go on the other side, -1, -2, and -3. Hopefully this won't take too long. Okay, it's a nice simple function to plug into, so it's not so bad. So substitute in 1. 1 plus 1 is 2 over 1. So I get 2 over 1 or 2. So the point 1, 2 is on my graph, and wow, I can actually tell already that does come in really close to this corner. Let's plug in 2. 2 plus 1 is 3 over 2. So I end up with 3 over 2, or 1.5. So at 2, I'm at 1.5. And then I could plug in 3. I get 3 plus 1 is 4 over 3. 4 over 3, which is 1 and 1/3. So 3, I'm at 1 and about 1/3. Okay, and I get something like this. Let's plug in -1. -1 plus 1 is 0. Oh, yeah, we're at 0. That makes sense. 0 over -1 would be 0. Okay, that was our x-intercept. At -2, -2 plus 1 is -1 over -2. So I get -1 over -2, which equals +1/2. So -2, I'm at +1/2. And of course, when I plug in -3, -3 plus 1 is -2 over -3, which is equal to +2/3, a negative divided by a negative. So I'm at +2/3, a little bit higher. And my sketch is going to be awful with this pen, so bear with me. But we get closer and closer to this asymptote as we go off to the side. We curve through these points, and then we got to curve and shoot down towards this vertical asymptote. Okay, and same thing up here. I get closer and closer to my vertical asymptote, smooth curve through my points, and get bounded by that asymptote as well. And there's my graph. Okay, that one wasn't too bad. Nice, easy function to plug into. Okay, let's take a look at our next one. So same idea, I just listed them up here again, give myself a graph. So let's take a look at this one. So first thing I want to do is try to simplify and look for holes. So I see the bottom's a quadratic. The top I really can't do anything with, but let's try to factor the bottom out. Are there factors of 8 that subtract to 2? Well, 4 and 2 do, so it should be factorable. So this negative 8 tells me I have opposite signs for my factors, x plus and x minus. And the factors of 8 that subtract to 2 are 4 and 2. And to add up to negative 2, the bigger factor, 4, has to be negative. So here's my factors in the bottom. Up top I have x minus 2, and nope, nothing ends up canceling out. So I don't have any holes. No holes in this graph. Okay, but the factoring will help me find some of my points in a minute anyway. Okay, next I want to find my y-intercept. So I'm going to plug in 0 for x. So if I plug in 0 for x, I can do that in the original or in the factored one. I'm going to go in the original because I think it's going to be easier. Because if I plug in 0 here, the only thing left up top is negative 2. When I plug in 0 here, 0 squared is 0, negative 2 times 0 is 0, those terms disappear, and I'm just left with negative 8. And so this ends up being 1/4. That's my y-intercept. So my y-intercept is the point 0, where we plugged in 0 for x, and 1/4 for y. So 0, 1/4, somewhere in there. Sorry, my pen is not very accurate. Bear with me. All right, the x-intercept. Let's find our x-intercept. This is where my numerator is set equal to 0. So when does x minus 2 equal 0? Well, obviously you add 2 to both sides, and that's when x equals 2. So my x-intercept is 2, 0. So 2, 0. Those points on my graph. Okay, next I need to identify any vertical asymptotes. And those are the values that make my denominator 0. So the two values that will make my denominator 0 are negative 2. We're just using kind of that 0 product property. Negative 2 and positive 4. My vertical asymptotes are at x equals negative 2 and positive 4. So we have two different equations of two lines here. So x equals negative 2 and x equals positive 4. Okay, so x equals negative 2, oh gosh, this button, and x equals 4. Okay, next we're going to try to find any horizontal asymptotes. What happened to that A? My horizontal asymptote, we're going to look at the degree of the top and bottom. Obviously this one is bottom heavy, and if you remember from our last lesson I said you can really think of this as it having 0 x squareds if you wanted to do the ratio of the leading coefficients, and 0 divided by 1 is 0. Or when the bottom has the higher degree, it's always just y equals 0. In other words, the x-axis plays my asymptote. Okay, and if you remember a little bit from last year, when we have kind of 3 sections of our graph like this, when we have multiple vertical asymptotes, sometimes your graph ignores the horizontal asymptote, but only in the middle section. So it might pass through here, and my guess is it probably kind of squiggles down through here, and then does something in the corners. Okay, so we'll definitely need some extra points to figure out what's going on in those sections. And so let's do that. That's our next point, is to make a table, get multiple x and y values here. So I know at negative 2, this thing is undefined, and at 4, it's undefined. And I kind of have an idea. Usually you have either like a U shape in the top and bottom, or it makes some kind of S shape one direction or another. And so I kind of have an idea with the current points we already have that it's most likely going like this, coming down and curving through those 2 points. Pretend it goes through both and then curves again. Okay, we're always bounded by the vertical asymptotes, but in this middle section sometimes they just go right through the horizontal one. Okay, so because I already have a couple points, I can see 1 point on the line, 1 point below the line. I'm pretty sure it's doing this. So I'm going to kind of skip plugging in points in the middle. Well, just to be sure, maybe we'll plug in -1 or something to see what's going on there. Okay, But I'm more interested in what's happening over here. Am I in this top area or in this bottom area? And how close am I coming into that corner? So let's pick a couple values, maybe -3 and -4. -3 and -4. And for me, it's probably easier to plug in the factored version here. So if I plug in -4, I'll get my work up here. I'm going to have -4 minus 2 over -4 plus 2 times -4 minus 4. Well, that gives me -6 up top. I'm going to end up with -2. And -4 and -4 is -8. So I end up with -6 over positive 16, which is -3/8. So something just a little less than -1/2. Something just a little bit less than -1/2. So a little bit closer than -1/2 at -4 there. Something like that. Okay, so that already tells me I'm in this bottom section, not in the top one. Okay, that's good to know. I could plug in -3. -3 minus 2 is -5. I'm going to calculate some of these. -3 plus 2 is -1. And -3 minus 4 is -7. So I end up with -5 over positive 7, which is under -1. So probably somewhere in here-ish, without finding the actual decimal value. And so that tells me my graph is going to be bounded here. It does come in pretty close. And then, of course, it's still bounded by my vertical asymptote down here. And again, that should look like it's getting closer and closer to that line. It shouldn't look like it's curving away, but just bear with my terrible drawing. Okay, on this side, same thing. I want to pick a couple points, 5 and 6, figure out what's happening over here if we're in the top or if we're also in the bottom. So if I plug in 5, 5 minus 2 is 3. 5 plus 2 is 7. 5 minus 4 is 1. And I end up with 3/7. Okay, which is something a little more than half. No, sorry, a little less than half. A little less than half. It's a little less than half at 5. Okay, not too bad. Plugging in 6. 6 minus 2 is 4. 6 plus 2 is 8. And 6 minus 4 is 2. So I get 4 over 16, which is 1/4. I think I did that right. 6 minus 2 is 4, 8, and 2. Yep. Okay, looks good. Okay, so this time we're up here. Again, bounded by my vertical asymptote, comes in very, very close. And then bounded by my horizontal asymptote. And there we go. There's a pretty good rough sketch. 3/7. Pretty good rough sketch of what's going on by hand with this graph. Okay, let's try one more. Obviously, these are time consuming, so you just got to bear with them. This one, there is no sum of squares. And remember, I cannot cancel out x's when there's addition or subtraction in the top and bottom. You can only cancel out like quantities. So there's no simplifying, there's no holes in this graph. So let's go straight to our y-intercept. Okay, that's where I plug in 0 for x. 0 over 0 squared plus 1, which is 0 over 1, which is just 0. So that tells me my graph actually passes through the point 0, 0. Goes through the origin. Next I want to find my x-intercept, and that's the value of x that makes the numerator 0. When does x equal 0? Well, when x is 0. So that actually gives me 0, 0. Hey, that's both my x and my y-intercept. What do you know? Okay, next my vertical asymptotes. So when does the denominator equal 0? So when does x squared plus 1 equal 0? Well, this is an easy enough one. I could solve it with square roots. Subtract 1, x squared equals -1, and take the square roots, and I get x is equal to plus or minus I, which means my vertical asymptotes are, well, they're imaginary. There's actually no real number that gives me a vertical asymptote. This graph doesn't have any vertical asymptote. Okay, interesting. What about my horizontal asymptote? So that's going to be, we look at the degree of the top and bottom. In this case, the degree of the bottom is bigger. Again, if you want, you can think of this as having 0x squareds, and then compare those leading coefficients. 0 over 1 is 0, but basically y equals 0. It does have a horizontal asymptote at y equals 0. Okay, so because this is such a strange graph, it doesn't have any vertical asymptotes, no real vertical asymptotes, let's pick a few points and figure out what's going on in this graph. So let's see, so there's no x value. I already know when x is 0, we get 0. So let's kind of spread these out a little bit this time. Let's go with like, you know, like 2, let's do like -2, maybe -6. Let's go like +2, +6. I'm just kind of spreading them out because I really want to know what's going on, not just in one little confined area of my map, my graph, but a pretty big section. Okay, so let's plug in 2. So when I plug in 2, I get 2 over 2 squared plus 1, which gives me 2 over 4 plus 1, or 2 over 5. Okay, so we plug in 2. I get 2/5, which is like 0.4 as a decimal. 0.4. Okay, that doesn't tell me too much about my graph yet. Let's plug in 6. Ooh, that's going to give me a really, really weird value. Okay, so we're going to plug in 6. I get 6 over 6 squared plus 1, which is going to end up being 6 over 36 plus 1, or 6/37ths, which is something a little less than a sixth. It's kind of weird. It gets smaller again. It's even smaller. I don't know. You know, maybe let's, so this is 1, or 6/37ths. Let's plug in 1 just to be sure what's happening. Pretty close to 1 here. When I plug in 1, I get 1 over 1 squared plus 1, which ends up being 1/2. Okay, interesting. So I get 1/2. Let's see. I'm going to go ahead and squeeze in -1 as well. When I plug in -1, I've got -1 over -1 squared. Remember our parentheses there. So -1 squared becomes +1. And I end up getting -1/2. And my guess is it's going to kind of mirror what's happening here. So let's try that. -2. -2 over -2 quantity squared plus 1 gives me -2 over 4 plus 1, or -2/5, which is like -0.4, something just a little bit lower. And I'm sure when I plug in -6, we're going to get -6/37ths. This was -2/5, and this was -1/2. Okay, and so what happens is it looks like this guy's getting closer and closer to this asymptote. It's doing something weird like that. What a strange graph. Just to be sure, I'm going to open up the graphing software here. Okay, there we go. I got it all plotted in. Let's take a look at what this weird thing does. Oh, I don't have the windows selected. And yeah, kind of a strange graph. We can see it here. It does match kind of what we estimated. It's a little weird, but came up with a pretty good sketch. Okay, so that's it. We will talk about when you get non-horizontal asymptotes, like slant asymptotes and other asymptotes next time. But that's it for now.